Now let's move to the partial pooling model. And the first thing that we're going to do is that we are just going to try to continue this notion of varying intercepts. So let's consider, again, the simplest multi-level model where students, again, indexed I, are nested within schools, which we are indexing with J. So if I remember correctly, there were about 73 schools, right? So J, capital J would equal 73. Now, we have no predictors right now. We are not having any predictors either at the individual nor at the school level. But we're going to try to write a two-level model that allows for varying intercepts with no predictors using this kind of two-stage formulation that we were talking about, where we have an individual level and we have that secondary level with schools where we're varying our alphas. So we're going to write this in the exact same way that we did before. The only difference is now you can see that the conditional mean here is actually alpha j sub I. So that means that we have to go up to the next level here, and we will again have varying intercepts alpha j that have a mean and their own variance here. So this is how we're going to be able to capture the variance within as well as across schools. So to reiterate, YI here is the examination score for an individual student who is subsetted or nested within a school. The alpha j's are the varying intercepts. So again, remember we're going to have different estimated regression lines here for each school. And those estimated points where they start and cross the y-axis is going to be different now. That is what we are allowing to vary. What we are not allowing to vary is the angle of those intercepts because we don't have any covariates here. The mu of alpha is the overall mean across schools. So this is what our overall effect is going to be because it is at the school level. Then when we get an mean of those alpha j's, that's going to be the weighted average of mean students in school J divided by the overall mean. So this allows us to determine how much individuals from schools are impacting the overall result. So this is why I was talking before about how we are going to use information from other schools to help us model the variance across schools as well as within. So I want to stress again that this model is only going to include a constant term that's going to vary by school. We are not going to include any covariates here. And the function that we're going to use in R in order to run a multi-level model is LMER. And for this partial pooling model, we are only having an intercept here at the individual level, no covariates, and we're allowing these intercepts to vary by school. So the syntax here for varying intercepts is to have one with the vertical bar and then school. I still see many people putting the data as the data $ and then their variables. Please do not do this. This is very important for the syntax with LMER. I don't know if you're going to be able to get away with doing that in this instance. So please just put data equals at the end of your LM, GLM, or LMER functions. Once you estimate and run your model, you'll then get the results back. Here again, since we have no individual level covariates, all we are doing is estimating an intercept. The fixed effects here is just an intercept. What we did is we also allowed the variance to vary by school, and that's what's found here in the random effects. So we'll go through exactly how to interpret that in a couple of slides, But this is how we start off by running our partial pooling model without any covariates at an individual or group level with just varying intercepts by school.